Hey everyone, welcome back to my YouTube channel, Act 1. The Anomaly, the Cosmos, is a tapestry woven with stars, galaxies, and the intricate dance of planets around their parent suns. For millennia, our understanding of planets was confined to those luminous worlds orbiting our own star, the Sun. Then, with the advent of powerful telescopes and sophisticated detection methods, we began to uncover a dizzying array of exoplanets, worlds orbiting distant stars, each with its own unique characteristics. From scorching hot Jupiters to super-Earths, the universe revealed itself to be teeming with planetary bodies. Yet, within this grand cosmic ballet, there exists a profound and unsettling mystery, a whisper of worlds that defy our conventional understanding. Lost planets. These are not planets merely distant or obscured by cosmic dust. These are worlds unbound, adrift in the cold, dark expanse between star systems, true cosmic wanderers. Imagine a world, not bathed in the comforting light of a star, but perpetually shrouded in twilight, its surface illuminated only by the faint, diffuse glow of distant galaxies. This is the desolate existence of a rogue planet, a planetary nomad ejected from its birthplace, cast out into the interstellar void. For generations, the very concept of such worlds was largely theoretical, a fascinating but unproven byproduct of violent planetary formation. How could a planet exist without the gravitational embrace of a star? Where did they come from, and more importantly, how many of them might be out there, hidden in plain sight, silently traversing the galactic planes? The sheer emptiness of interstellar space makes their detection an almost insurmountable challenge. They emit no light of their own, reflecting none from a nearby star, making them virtually invisible to our most powerful instruments. Yet the scientific community is increasingly convinced that these lost planets are not merely figments of our imagination, but a significant, perhaps even dominant, population of planetary bodies in our galaxy. The mystery of these rogue worlds, their origins, their prevalence, and their ultimate fate represents one of the most compelling frontiers in modern astronomy. It challenges our very definition of a planet and forces us to reconsider the cosmic landscape we thought we knew. The universe, it seems, holds secrets far stranger and more numerous than we ever dared to imagine. Act 2. The first clues the idea of planets existing independently of stars isn't entirely new. Early theoretical models of planetary system formation, particularly those involving gravitational instabilities and close encounters between young protoplanets, often predicted that some nascent worlds would be flung out of their stellar nurseries. These early predictions, however, lacked observational evidence. The sheer difficulty of detecting an object that is neither luminous nor orbiting a star meant that for decades, rogue planets remained firmly in the realm of hypothesis. The first tangible clues to their existence began to emerge not from direct observation, but from the subtle gravitational distortions they impart on background light. This revolutionary technique, known as gravitational microlensing, became our primary window into the world of unbound planets. Gravitational microlensing relies on a phenomenon predicted by Albert Einstein's theory of general relativity, that massive objects warp spacetime, bending the path of light rays that pass near them. If a rogue planet happens to pass directly between Earth and a more distant background star, its gravity can act like a cosmic magnifying glass, temporarily brightening the light from the background star. This brightening event is brief and unpredictable, often lasting from hours to a few days, making it incredibly challenging to detect. The first strong candidate for a rogue planet detected via microlensing was announced in 2011. This object, designated CFB DSIR 2149-403, was initially identified as a free-floating planetary mass object in the constellation Aquarius. Its estimated mass was between 4 and 7 times that of Jupiter, and it was located about 100 light-years away. While its classification as definitively rogue was debated, given the possibility it could be a very faint brown dwarf, it sparked immense excitement and focused attention on the microlensing technique as a viable method for finding these elusive worlds. Other early microlensing events also pointed towards the existence of objects with planetary masses that were not gravitationally bound to stars. These initial discoveries, though few and far between, provided the first concrete evidence that the theoretical predictions might indeed be accurate. The challenges were immense. Microlensing events are rare, they are non-repeatable for a given object, and the mass estimates can have significant uncertainties. Yet, these early successes demonstrated that with persistent observation and sophisticated data analysis, the universe was beginning to reveal its hidden population of wanderers. The scientific community, once skeptical, began to embrace the possibility that rogue planets were not an anomaly, but a fundamental component of galactic ecology, awaiting discovery. Act 3. Modern investigation asterisk today, the hunt for lost planets has intensified, fueled by more powerful telescopes, advanced data processing techniques, and a deeper understanding of planetary dynamics. While direct imaging of rogue planets remains incredibly difficult due to their lack of intrinsic light and immense distances, Gravitational microlensing continues to be our most prolific detection method. Observatories like the Optical Gravitational Lensing Experiment, or OGLE, based in Chile, have been instrumental in scanning millions of stars in the galactic bulge, constantly searching for the telltale brightening signatures of microlensing events. The sheer volume of data collected by these surveys has allowed astronomers to not only detect individual candidate rogue planets, but also to begin estimating their overall population. Studies using microlensing data suggest that rogue planets